Now let's do some examples about inverse relations. So this objective one, we're going to find the inverse relation, and then in this one, we're going to graph both sets of points. Just for example one, for part B, we will just find the inverse relation. And when I say relation, this can be represented in multiple different ways. So for example, part A, we have 3 different points, 1, 1, 1, 4, and 4, 6. In part B, we have a table. Sometimes we may be given a graph, or maybe we're given a formula or a function or an equation. There are lots of different ways to show the relationship between x and y. So we're going to do examples with lots of different kinds of relations. So finding the inverse relation, remember that we swap x and y. I'm going to write that down, which means to find this new set of points, we will swap x and y. So for this first point, it actually doesn't change the point. In our minds it does though. So then the second point will become 4, 1, because we swap the 4 and the 1. So the 4 right here is in the y, now goes to the x. This 1 is in the x value, this one goes to the y. Also, I guess I should remind that coordinate points go x, comma, y. And then our last point will be 6, 4, because we swap that 4 and 6. Now, let's graph these and find what we observe. So let's graph 1, 1. I'm going to graph the inverse first because I'm writing in purple. So then we're going to graph 4, 1. So we go over 4, up 1. And then we go to 6, 4, which is over 6, up 4, right here. And I'll graph my other equation in, maybe we'll do like a green color. So I'll do this one in green. So we'll graph 1, 1 again. These overlap. 1, 4 over 1, up 4. And then 4, 6 over 4, up 6. And I'm also going to draw these triangles just for the sake of helping you see what's really going on here. I'll go back to my pink color, or at least I'll try. And this one looks like this. You see how they look very similar to each other? They're just kind of flipped over a certain line. And remember what that line is. That line is the line y equals x, which goes straight diagonally across our coordinate grid. So, what do we notice about the graphed points? They reflect over. They reflect over the line y equals x. And that's what's special about inverses. They'll reflect over this diagonal line y equals x. All right, now let's take a look at part B. We have an input-output table. And just remember that input always corresponds to x and output always corresponds to y. So we'll create an inverse table where we're going to swap the x's and the y's. All right, so one way we can represent this is through a table, but I think for our purposes, it'll be more friendly to look at this table like a set of points. So this point is 0, 2. This first point right here, x is 0, y is 2. So what would be the inverse point? 2, 0. Because we switched that x and y. So I'm going to draw an arrow. I'm going to write inverse so we know what we're doing. So the inverse is 2, 0. What's another point? This point is 2, 4. So if we switch that x and y, this is going to be 4, 2. The third point is 4, 6. So if we swap those x and y values, we will get 6, 4. And then our next one is 4, 8. So our inverse will be 8, 4. And I'll keep going. The next one will be 10, 2. And then the one after that will be 12, 0. All we're doing is switching those x's and those y's. So this would be good for an answer right here, because we showed that given these points, these are all of the inverse points. And I'm not going to graph these, but just know that if you were to graph all of these points, they would reflect over that line y equals x. All right, now let's move on to objective 2. This is going to get, we're going to work more with formulas now. And I also added this picture to kind of help us with inverse relations. So I'll talk about this first. So if we're starting with x, we're going to multiply by 2, and that becomes 2x. And then we're going to add 3, and that becomes 2x plus 3. Now let's say we wanted to solve for, or get that x back by itself. Like, what would we do? So we would say this is equal to y. And then we would end up saying, well, we added 3, so now we have to subtract 3. And then we had multiplied by 2, so the opposite, or the inverse, of multiplication is division. So then we divide by 2. Which means the inverse of 2x plus 3 is y minus 3 over 2. Which we'll talk about, and this is going to be an example of that. So let's let f of x equals 3x minus 5. We're going to solve y equals f of x for x, and then find the input when the output is 4. All right, so this objective, we're going to write the formula for the input of a function. Remember that input is always the x value. So this means we're going to solve for the input, or write for the input, which means we are going to solve for x. Which really means get x alone. So we have a function f of x, which is function notation. That's what that f of x is. That's how you know that something is a function. And remember that a function is a special kind of equation. So another way we can write this right here, f of x equals 3x minus 5, is just y equals 3x minus 5. And then I think that'll make more sense for you. So what we need to do now is solve for x. So we need to get x alone. So how do we do that? What's our first step? First, we need to get this 3x term all by itself. So how do we get rid of this minus 5? We do the inverse operation, which is adding 5. These are plus signs. So what do we end up with over here? These terms don't combine, so we just end up with y plus 5 equals, these 5's will cancel out, and we are just going to be left with 3x. Now, how do we get x alone? We have 3x, how do we get x alone? We're going to divide everything by 3. Since we're multiplying by 3 here, the inverse of multiplication is division, so we need to divide by 3. And here, okay, make sure you're watching this. Make sure we divide this whole thing on the left-hand side by 3, both terms. So let's go up here. What is our formula for x? Or formula for the input? What are these 3's going to do? They're going to cancel, and we're going to end up with x equals y plus 5 over 3. So we just solve for x, which is the formula for the input. So this is kind of backwards. It's the inverse of how we normally look at equations, because x and y, we solve for x. Normally we have it solved for y. So now we need to find the input. And remember that input is the x. when the output is 4. And remember, the output is y. So we're looking for when y equals 4, what is x? So we're going to go right here to this x equals y plus 5 over 3, plug in 4 for y, and then solve for x. So we end up with x equals y, which is 4, plus 5 all over 3, which if we simplify this, 4 plus 5 is 9. 9 over 3, 9/3 is really just 3. So that means the input is 3 when the output is 4. So we did a lot. I'll just do a quick summary. So we started with f of x equals 3x minus 5. Change that to y equals 3x minus 5, and then we solved for x. So we did a lot of inverse operations, and we ended up with x equals y plus 5 over 3, which is your formula for the input. And then we had to solve a problem, so we had to find the input, which is x, when the output was 4, when y was 4. So we plugged in 4 for y, and then solved for x, and we ended up with 3 equals x. All right. Let's keep going. Last objective, last problem. I can find the inverse of a function using algebra, which is very similar to what we just did. All right, objective 3 again. So this is very important. We're going to write the rules for how to find the inverse of a function using algebra. So step 1, remember that the inverse is when you switch x and y. So that's actually what we're going to do. So step 1 is going to be switch x and y. X and y. And remember that we can write this as y equals, instead of f of x equals, 3x plus 4. So, step 1, we are going to switch x and y. So, we're going to write x equals 3y plus 4. And then we are going to solve for y. So that's step 2. 2 steps. Switch x and y, and then solve for y. So we'll go ahead and do that right here. Solve for y. We need to get y by itself. How do we do that? Well, first, we need to subtract 4 from both sides. So on the left-hand side, we end with x minus 4 equals 3y. Now, how do we get y by itself? We do inverse operations. So we divide by 3 on both sides. Make sure you divide this whole term by 3. And we end up with, these 3's will cancel, x minus 4 all over 3 is equal to y. Now I'm going to introduce some new notation, okay? The symbol for inverse, I'll put this as a star here. Symbol for inverse is, for an inverse function, is f with the little negative 1 as it's not an exponent, but it looks like 1 of x. And this is like this new y. So our inverse function is going to be f inverse, that's how you say this, you say f inverse of x, that's what these little parentheses are on the x side, so of x, it's a function of x. So f inverse of x equals x minus 4 all over 3. And this is our inverse function. So the inverse of f of x equals 3x plus 4 is f inverse of x equals x minus 4 over 3. And that's it for this set of notes, but I'm also going to add one extra video of doing one more example problem if you choose to watch it. So that's it. Email me if you have any questions at all about